Hello students and welcome to today's lecture, which is going to be on IUPAC nomenclature, or how we name these different molecules. Okay, and the naming of these molecules follows a complex set of rules, but in general it's going to be a fairly easy thing for us to go ahead and work with and practice. And the number of molecules that we'll have to do on the actual final exam are going to be some fairly easy ones in terms of the naming for us. Okay. So first what we'll have to do is we're going to go ahead and identify the family. And remember, the family is going to be dependent upon all the different functional groups. So if it has an alcohol, that goes into the alcohol family. And if it's an ester, that means that it's going to go into the ester family. Okay. And we're going to have a cheat sheet for this as well. But the most that I need you to know is that we're always going to go ahead and have a family. And then if there is no family, so then it'll be an alkane, which is the ane. Okay? And essentially what will happen is that we're always going to go ahead and have three parts to it. We're going to have the prefix, we're going to have the parent molecule, which is essentially going to tell us how much of each molecule that there is, and then we're going to have the suffix, which is what it's going to end with. So whether it's an ane, ene, all as in alcohol, carboxylic acid, all of those are going to go ahead and be in the end right there, in the suffixes, okay? So the suffix is the thing that goes on at the end, and it's going to tell you what the major family of it is, okay? So the end is the major family, okay? Basic part, the parent part is going to tell you how many carbons that there are. Okay, this is going to be essentially where we're going to be counting our different carbons to see how many there are and using a prefix for that. And it's also going to be defined by the longest continuous chain of carbons. So that's going to be something that we're going to want to keep in mind there. Okay. The parent and suffix, the parent is one carbon is going to be meth. It's a alkane because it doesn't have anything else attached to it, and therefore it's going to be methane. Therefore CH4 ends up being methane. Okay. 2 carbons is eth, therefore it's going to be an alkane still. There's nothing special, so therefore this molecule is going to be called ethane. 3 carbons is called prop, so 3 carbons together is propane. 4 is bute, and so 4 is going to be butane. Okay, 5 carbons will be pent, 6 carbons will be hex, 7 will be hept, 8 will be oct, 9 will be non, and 10 will be dec. Okay. So here, this one here, 1, 2, 3, 4, 5, 6, 7, 8, 9. This is going to end up being nonane. Okay. Should you have 2 or more chains that are the same length, the parent is going to be the one with the most prefixes. Yeah, okay, that'll make sense in a second. All right, prefixes are going to be the things that end up going before the bit of information that we just gave. Okay. And a prefix is going to be anything extra that's kind of attached to the main chain parent. So an example here is that we have a alkane here, and on this alkane we have a bromine, and we have to indicate that, and we're going to indicate that with a prefix. Okay. The family called alkyl halides does not have a suffix, therefore we're always going to go ahead and use the prefix to go ahead and indicate what's going on there. If it's a fluorine, we're going to say fluoro, chlorine, chloro, bromine, bromo, iodine, iodo. Okay. In general, we're going to go ahead and find our main chain, number the main chain, identify all the prefix and their position numbers, and then we're going to go ahead and write it together. This right here, it's on 1, 2, 3, 4, so it's on the 4th. 5, 6, 7. So this is going to be 4 bromo heptane. Okay, this will be heptane. It's on number 4. 4-bromoheptane. Okay, and that's how we end up solving the name for all of these here. Okay. This one, notice that it is an asymmetrical one. Since it's asymmetrical one, we're going to make sure that we count it in a way that makes sense. And the way that's going to make sense is that we're going to count it so that the prefix is going to be closest to the start of our molecule. So we could theoretically go 1, 2, 3, and this will be 3-bromoheptane, or we could go 1, 2, 3, 4, 1, 2, 3, 4, 5, and this could be 5-bromopentane. Since we are trying to minimize the amount of counting we do, we're always going to go from the left side or the right side, depending on which side it's closer. And we'll go ahead and have this be its official name of 3-bromoheptane. Okay, we're always aiming to have the lowest possible number for the first substituent. Okay. We also have prefixes for carbon groups that are attached to the main chain. Okay, so when we have carbon groups that are attached to the main chain, we will end up calling them alkyl groups. Okay, and we end up saying that they are alkyl groups, and we'll add an EL to the end to indicate that they are just a fragment of a larger molecule there. Okay, so for instance, when we have a CH3, which is a fragment of methane, it's a methyl group, okay? And so you can imagine that we have a straight chain molecule where we have a single methyl group coming off of here, okay? So this would be 4-methylheptane, okay? Here we have an ethyl group coming off. This is 4-ethylheptane, okay? Propyl groups. We're going to go ahead and have two kinds. We have N-propyl or propyl groups, which is a normal one where the where we have a straight chain going on, and that's what's known as a propyl group. We also have the chance for an isopropyl group, where we have the center carbon essentially asking for a breaking off point. So be aware for a propyl group that that's going to be an that you can either have a straight chain one, which is known as N-propyl or propyl, and you also have the isopropyl, which is be where we have this divergent in the middle one right there. Okay. Okay. This is asking us what alkyl groups do we see. We have two groups that are attached to this ring. We have this group right here, and we have this group right here. So right here we have an ethyl group. Here we have an isopropyl group. Okay. Every prefix needs a position number. This is so that when we write it in, alphabetically. Okay, so that means that if we were writing it in and we had an ethyl group, a methyl group, a propyl group, and an isopropyl group, we would say the ethyl group first, the isopropyl next, the methyl group, and then the propyl group. Okay. If you have two multiples of the same prefix, like in this example right here, we have two bromines, what you could name them separately, or you could combine them. Okay. So an example here, we put 3, 4, indicating both the positions, dibromohexane. Okay. That's indicating that we have on the third and fourth, we have our bromos, and that there are 2 of them total. Okay. Again, remember, we're going to probably also have di, tri, tetra. That's based off of how many methyl groups or alkyl groups or haloalkyne groups that we have. Okay, wants us to go ahead and name this group right here. Okay, as a reminder, this is going to be our lowest one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we have no name. Here we have a methyl group on 4. So 4 methyl. We have a 5 isopropyl. Okay. So we would put 5 isopropyl, 4 methyl, no name. Okay. Okay. Recall here. Let's take a look at this one. This is our carbon. We're always going to pick the one with the longest chain. Okay. So be aware of that. 1, 2, 3, 4, 5, 6, 7, 8, 2, 3, 4, 6, 7, 8. Looks like the parent is the same. There's 2 options. And we're going to go with the blue one because it has 3 branches. So the one that has the most number of branches is going to be the one that's going to be easier to name here. Okay, so this one is going to be the, let's see, we have a 2-methyl, we have a propyl, and we have a 6-methyl. So it should be 2,6-dimethyl 5-propyl octane. Okay, because this branch of 3 is coming off here. Okay, cyclical compounds, the same thing is going to go with counting for our cyclical compounds. We want to make sure that the number is the smallest one. Okay, so for instance, this one, we want to make sure that we have the smallest total numbers when we add them up. So we could theoretically go from here, 1, 2, 3, 4. Okay, 1 plus 2, 1 plus 3 and plus 4 is going to equal 8. Or we could go this way, 1, 2, 3, 4. Okay, this would be 7, which means that we want to go around this way right here when we go ahead and name it. Okay, and this is going to end up being one of these things that as we practice with naming, it'll end up getting quite easier for us to go ahead and name them. Most of naming is just counting and making sure that we put the right groups on, the right functional groups on to our molecules as we go through. And then in class again also we'll go ahead and go over how to do the naming when we have different functional groups on there and how we indicate that on there. Usually it's going to be a dash and an indication about what carbon it's going to be on. For now, we're going to go ahead and close down, and I hope that you all have a wonderful time doing your worksheet. It's late here. I'm recording this at 3:17, so I was going to say evening. All right, you guys all have a good one and stay lazy.